Saxenda is the only glucagon-like peptide 1 or GLP-1 analog approved for weight management in adults with obesity or who are overweight with one or more weight-related comorbidity, such as hypertension, dyslipidemia, or dysglycemia. Multiple signaling molecules involved in the regulation of appetite and food intake are released from the gastrointestinal tract and brain in response to food intake and fasting conditions. The arcuate nucleus of the hypothalamus contains two distinct neuronal populations that play a central role in translating these signals into feelings of satiety or hunger. Hunger is regulated by neurons that produce the neuropeptides AGRP and NPY, while satiety is regulated by neurons that produce the neuropeptides POMC and CART. Glucagon-like peptide 1, or GLP-1, is a physiological regulator of appetite that increases satiety and reduces hunger and food intake. GLP-1 receptors are expressed in several organs, including the brain, pancreas, and gastrointestinal tract. When food is absorbed from the gut, GLP-1 is released, predominantly by intestinal L cells. It is also released from the nucleus of the solitary tract in the brain. GLP-1 is a 31 amino acid peptide. After its release into the circulation, GLP-1 is rapidly degraded by the enzyme DPP-4, resulting in a short half-life of less than 2 minutes. Saxenda is a GLP-1 analog with 97% structural similarity with native human GLP-1. The molecule has two structural modifications that prolong the half-life and time in circulation, the addition of a fatty acid side chain and a single amino acid substitution. Following subcutaneous administration, Saxenda molecules group together, which improves stability and delays absorption. Once released into the circulation, Saxenda binds to albumin through its fatty acid side chain, protecting it from DPP-4 degradation. These actions combine to prolong the half-life to approximately 13 hours following subcutaneous administration, allowing for once-daily dosing. Studies in animal models have shown that peripherally administered Saxenda interacts with GLP-1 receptors in the brain, including the neurons within the arcuate nucleus that are involved in appetite regulation. This causes a reduction in hunger by inhibiting AGRP-NPY neurons, and an increase in satiety due to the stimulation of POMC-CART neurons. A clinical study in people with obesity has shown that Saxenda treatment is associated with reduced hunger and increased feelings of fullness and satiety, leading to a reduction in food intake.